So this is the second video on the introduction to spur gears. Picking up where we left off, we were talking about conjugate action, which is action that allows the gears to maintain a constant ratio between the gears. So if the ratio is 3 to 1, it will stay 3 to 1, regardless of, as the gear teeth roll on each other. Right, you can see as they touch each other and move along this point of contact, the distance out from this driven gear right here is going to increase, whereas with a driving gear here, the distance out from the center is going to decrease. And so at first look, you might think, well, how can we maintain a constant angular velocity between the axles, because the gear teeth obviously can't have to be traveling at the same velocity at that point. They can't pass through each other, and the tangential velocity is going to be a function of the radius and the angular speed of the gear. So if the position is changing, then it would seem that to maintain the same constant ratio between the angular velocities would not be possible. We're not going to take the time to show with vectors and whatnot why that's true. I'll just point out that the tangential, or I should say this, if you drew a line out to the point of contact, it's not the velocity, the tangential velocity from that, or the velocity that's perpendicular to that line that has to stay constant, right? Because in fact, the velocities of those points in this direction are not the same, whereas in this direction they do have to be the same. At any rate, we're not going to take the time to do that, but it can be shown that if you use an involute curve, then you can achieve conjugate action. And in fact, there are other profiles, as stated down here. There are other tooth profiles, tooth shapes, that can also achieve conjugate gear tooth action, but the one that's commonly used is an involute curve. Okay, and that this is important. If you think about it, if that ratio were changing even slightly, if you were driving down the highway and the ratio in your transmission as or your rear end, whatever, was changing slightly, maybe it's 5 to 1, now it's slightly less than 5 to 1, then a little bit more than 5 to 1, constantly changing, you'd get a lot of vibration, which would be annoying and probably cause premature failure. So it's very important to be able to have gear teeth that allow you to have this conjugate gear tooth action. And the involute curve, of course, is just the curve you get. And if we had a pencil tied on a string and wrapped around a base circle here, and then move that away, keeping the string taut, then we would get an involute curve. Okay. So with the base, with the pitch circles now, remember that whenever we talk about gear, we talk about diameter. We're almost always talking about the diameter of the pitch circle. That's important. It gives us the ratio of the pitch diameters, gives us the ratio of the gears. If the pitch diameter on this gear was half of the pitch diameter on this gear, then this gear would have to rotate twice to get this one to turn once. And the other important thing about the pitch circle is we need to know pitch circle diameters, is that's what we use to determine the center to center distance, right? This distance C, you just add the two pitch diameters together and divide by 2. That way you know when you're designing your gearbox, you need to know where to put the axles, how far apart. It's critical with gears to get them the correct distance apart. So you use the pitch diameters, or the diameters of the pitch circles, to determine that center to center distance. Okay, so right now in this diagram you have the two pitch diameters, the two pitch circles, which again the gears rotate as if they were friction drums with the pitch diameters. And I'm actually going to have to do one more video, so we're going to stop here and I'll pick up with the next video.